Okay. Hello, dear colleagues. My name is Yana Shidlovska. I am Associated Professor in Department of Information Technology and Computer Engineering in Dnipro University of Technology. Our research is devoted to identification of objects on satellite images using image texture properties. Today, due to modern satellite, it is possible to obtain high-quality images of the Earth's surface. This remote sensing data are used in different areas of human activity, especially in agriculture. One of the important tasks of remote sensing data processing is counting of trees in
这是乌克
plantations.
兰人还是俄国人？俄罗斯的？
你觉得可能说是我们早上，他上次给我发邮件，说论文的文献都不能
I'm sorry.
用，就是。
Please, yeah. Okay.
Can you hear me?
Yes, yes, please.
Okay. And one of the important tasks is the counting of the trees in plantations in order to estimate the harvest. Orchards and trees in plantations can cover huge areas and have thousands of trees. So the task of automating harvest estimation is very important. To solve this problem, we proposed a method of image texture segmentation and counting of individual objects which make that texture. The task can be divided into two subtasks. First, the identification of areas of Earth's surface which correspond to agricultural plantations, and second is identification of individual objects in the selected area which corresponds to uniform texture. The modern satellites are able to provide high-resolution multispectral data due to the presence of red, infrared, and near-infrared parts of spectrum in this data. It is possible to assess the state and stages of crop growth and determine of vegetation type, and also determine the location of vegetation in images. In this slide, you can see the example of a satellite image that was processed. Analysis of different satellite and aerial photographs has shown that each image contains several types of land cover, which can be characterized by their spectral and textural properties. In this example, we processed satellite image by multi-resolution segmentation method on the basis of its spectral properties, but to identify uniform textures on the image, we used adjacency symmetry, so-called high-level core occurrence matrices. On the basis of high-level core occurrence matrices computation, we obtained several different textural features, and to determine the uniform areas of the image that corresponds to texture, we performed image segmentation over calculated texture features. At this slide, you can see the result of image segmentation on the basis of textural features and the delineation of the area which corresponds to a tree plantation. The region of interest was found using supervised classification methods of image processing. And after obtaining the region which corresponds to a certain texture, we can count the structural elements that make it texture. We proposed an algorithm for counting objects on satellite image. The algorithm consists of following steps. For identification of particular elements that make up the texture, the spectral characteristics of objects can be used. In case of vegetation or trees, we can use different vegetation indexes. For example, NDVI vegetation index. The calculation of the vegetation indexes showed that in some images, its value is too high in the entire area corresponding to the tree plantation. In this case, the histogram of the image is shifted from the center as shown in this figure. And this leads to the impossibility of distinguishing the objects that correspond to trees using the histogram thresholding. In this case, another spectral features of objects in images can be used. For example, the NSVDI shadow detection index. To obtain individual objects of texture, we performed image thresholding over spectral index histogram and obtained the binary mask of objects that make texture. The next step of the algorithm is counting of the objects. It can be realized on the basis of connected components of the image identification. And in this slide, you can see the result of individual objects identification. We propose a method of satellite images processing on the basis of texture characteristics of the image. We propose the algorithm for counting individual objects that make up the uniform texture. The estimation of algorithm work was performed on the basis of referenced data, where areas with different texture are marked. And the actual number of trees was calculated on the studied samples algorithm. The obtained results showed a sufficiently high accuracy of the calculation. Thank you for your attention. Your questions, please.
Thank you very much. Who from participants have a question to presenter?
I have a question. Have you used only 4 channels, that means RGB and one of infrared, or you tried to use all 8 channels from satellite image?
Yes, in order to calculate texture, we used 8 channels of the image because the data that was used contain 8 channels. This is World U3 satellite image, and methods of high-level co-occurrence matrix calculation used all 8 channel, and for spectral indexes calculation, the channels that are required for these indexes.
And when you converted to HSV, you used only one feature, S-V, S+V, or you or model used H, S, and V full time as features?
No, the conversion to HSV color model was used only for an SVDI index computation.
Have you tried to use H as a feature for model?
No, for this index computation, exactly this model is used. So in current task, we used only HSV color model.
HSV color model, but only for NSVDI feature, or HSV the input of model for processing.
Yes, I understand. HSV was used only for index computation. For model, we used initial 8-band data.
It was not.
It was not converted.
Okay. And was any profit from other 4 channels except RGB and infrared, near infrared?
Yes, they are used for gray level matrices computation to obtain more information about data.
Without feature extraction, model itself find something interesting in it. No other features except vegetable and index.
Only texture features calculated on the basis of high-level co-occurrence matrices, and vegetation index and shadow detection index was used.
And other channels were just for model for work. Maybe it find something in it to use.
Yes.
Okay, thank.
Thank you very much. Other questions, maybe somebody? No. Thank you, presenter. Going to next report. Yulia Gurova, Kirill Smelякov, Sergei Osiyevsky, who is present from
Yes, I'm here.
Gurova. Okay,
Present,
okay.
yes.
Please, you have 10 minutes.
Yes,
Please be in time.
Hello, I would like to present to make a presentation on the topic analysis of the effectiveness of using machine learning algorithms to make hiring decision. In this presentation, we review the relevance of the subject area and define the main objectives of the experiment. We review the methods and materials that were used to solve the problem. Also, we review the steps of the experiments and the result obtained. Finally, we summarize and formulate conclusions based on these results. Hiring is a critical process for organization. It has direct impact on business success, and poor hiring decision can result in significant negative consequences. Hiring process involves a set of steps to recruit, evaluate, and select new employees who can contribute to the organization's success. These steps typically include job posting and recruitment, resume screening, and initial interview, testing and posting, and background checks, final interview, job offer, and acceptance. The traditional hiring process can be time-consuming, costly, and subjective, leading to potential bias and errors in decision-making. As such, organizations have begun to explore the use of machine learning algorithms in the hiring process to improve its efficiency and effectiveness. The purpose of this work is to experiment with decision tree algorithms and determine the effectiveness of the use in the recruitment and hiring process. The task of the work are to perform a series of experiments using different machine learning algorithms, evaluate the effectiveness of each algorithm based on evaluation metrics, compare and select the most effective algorithms for making hiring or rejection decision. Consider the method and materials used for the experiment. And let's start with the preparation of data. The preparation of data set is a critical step in the process of predicting the suitability of candidates for a job. To solve the problem of hiring classification, it's necessary to collect relevant data on job candidates. This can be personal information about job candidates, such as their name, age, gender, educational work experience, skills data, feedback, or recommendation from the previous employees. The data set used for the experiment includes information about the candidates such as gender, work experience, education, internship score, salary, offer history, location, and recruitment status. The result attribute of our prediction is recruitment status. In the presented diagram, you can see the quantitative characteristic of the data set by routing attribute recruitment status. One of the many solutions in solving hiring problems is to use decision tree algorithms because they are well suited for classification problems, which is typically use case in the hiring process. Decision tree algorithms allow decision makers to evaluate different criteria for each candidate. The most common decision tree algorithms that were used in our work is decision tree, random forest, and gradient boosted trees. The presented diagram shows the structure of the decision tree, which consists of three main parts: the root nodes, the leaf nodes, and the branches. The root node is a starting point of our tree, and the root and leaf nodes contain the questions or criteria that need to be answered. The branches are arrows connecting the nodes and the root node is the starting point of our tree, and the root and leaf nodes contain the questions or criteria that need to be answered. The branches are rows connecting the nodes and showing the movement from question to answer. Each node usually has 2 or more nodes branching off it. Several evaluation metrics, including accuracy, precision, recall, and F1 score, were used to evaluate the effectiveness of our model. A high recall score indicates that the model effectively identifies positive examples, and it's defined as the ratio of the number of true positive as number of true positive examples to the total number of actual positive examples. A high precision index indicates that the model effectively determines only positive example, and it's defined as the ratio of the number of true positive to the total number of true positives. A high accuracy rate indicates that the model effectively predicts both positive and negative cases, and it's defined as the ratio of the number of correct predictions to the total number of predictions, and represents the proportion of cases that the model correctly classified. F1 score is the harmonic mean of precision and recall, and is used to evaluate the overall performance of the model in correctly identified positives instances, with minimizing the number of false positive and false negatives. Based on the algorithms that were presented on the previous slide, we developed software to train the model. To implement this software, we use the Java programming language using the Spark framework. The process of training a classification model involves several steps. The first step is to prepare the data for the model by cleaning and processing. The next step is to divide the data into 2 sets, a training data set and a test data set. For our experiment, the data set was divided in the proportion 80-20. In the presented diagram, you can look in detail at the quantitative characteristic of the data sets. After splitting the data into 2 separate sets, a decision tree algorithm is chosen, and the model is trained on the training data sets to learn how to make predictions. Once the model has been trained, it can be used to make prediction on the test data set. Prediction can be compared to actual values on the test data sets to evaluate the effectiveness of the model using evaluation metrics. After analyzing the evaluation metrics, the model can be fine-tuned to improve its performance. Consider the results of the experiment. The training time for the decision tree model is 0.803 seconds. The model achieved an overall accuracy of 74 and 75%. The training time for the random forest model is 0.964 seconds, and the model achieved an overall accuracy of 78 and 0.6%. The training time for the gradient boosted trees model is 1 and 728,000 seconds, and the model achieved an overall accuracy of 70 and 9%. random forest algorithm is the most effective in terms of achieved higher overall accuracy, precision, recall, and F1 score, outperforming both decision tree algorithms and boosted tree models in all metrics. However, the training time required for each algorithm varies significantly, with the decision tree being the fastest and random forest and gradient boosted trees taking longer. Based on the result, consider the summary. The random forest algorithm achieved the highest overall accuracy, precision, recall, and F1 score. The Gini index and entropy criteria had a minor impact on the performance of the tree models, with entropy slightly outperforming Gini. The effectiveness of each algorithm is highly dependent on specific variables, so it's so important to adjust these parameters to optimize model performance. And machine learning algorithms should not be used to make the final hiring decision, but rather as one of many tools in the hiring process. In conclusion, we can say that several experiments were conducted using different decision algorithms. The effectiveness of each algorithm was evaluated based on the evaluation metric, and the most effective algorithm for making hiring decision has been determined. Thank you for your attention. If you have any question, I will try to answer them.
Thank you very much. Maybe anybody have a question to reporter about how we use the software to hire some employees for you or prepare that data? No question. Then thank you, Yulia. We should be quick. I'm going to next report. Yes. Then next report is low illumination image enhancement method based on adaptive algorithm. Yeah, who will be a reporter?
Good afternoon, distinguished experts. Can you hear me?
Yes, okay. Please.
Okay.
You have 10 minutes.
Okay. I'm Nishong Wei, the author of the paper Low Illumination Image Enhancement Method based on Adaptive MSR-CR algorithm. Let me start my report. Images are an indispensable part of today's information age. However, because of weather, lighting, equipment, and other factors, low illumination images make up the majority of the images. Low illumination images generally contain more obvious noise, low brightness, and inconspicuous details, which are detrimental to subsequent computer vision and other applications while affecting the visual experience. Low light image enhancement has been extensively researched, but there are still two problems. Low illumination image enhancement has been extensively studied. It is difficult to balance the relationship between contrast enhancement and the naturalness. Conventional algorithms do not allow for adaptive adjustment of parameters to each image to achieve the best enhancement. We have two goals. First, algorithm parameters can be adaptively adjusted. Second, visible detail and vivid colors in the image. Now, I will introduce the Retinac theory and related algorithms. The Retinac theory is also called the retinal cortex theory. Retinac theory is the decomposition of a given image into illumination and reflection components. I is the image observed by the human eye. L is the information of the incident component of the object and the core part of rednecks. R refers to the reflected part of the object. Since the logarithmic from the is closest to the properties of the process with which one perceives luminance, it is usually transferred to the logarithmic domain for the solution, which also transforms the complex multiplication into addition and subtraction. The illumination image enhancement method based on the adaptive MSRCR algorithm is proposed to address the problems of the rednecks algorithm in processing low illumination images, such as the need of manually adjust parameters and blood details. The algorithm is mainly divided into 3 parts. First, separate the detail level image of the input low illumination image, and then some image details are enhanced according to the weight value set after the algorithm optimization. Second, according to the carefully set fitness function, LLSSA algorithm optimizes the parameters of 3 Gaussian kernels, gain, offset, and the detail layer weight in MSRCR, and achieves the best image quality enhancement for the differences of each image. Second, the original image and the detail image according to weight to generate the final enhancement image. Self-swarm algorithm is a population intelligence optimization algorithm, which is compilation small and simple to understand. It has been widely studied and applied once proposed. Since there is no guidance of prior knowledge, the standard SSA adopts random initialization. Chaotic sequence helps the algorithm improve the ability of global search. Therefore, in this paper, logistic chaotic mapping was used to initialize the population of cells. And when processing complex image enhancement, the results obtained by standard SSA are not satisfactory. The randomness of step size and the direction of light wave flight can improve the algorithm diversity and effectively to jump out of the local optimal solution. Introducing the light wave flight step into the update of the position of the leader and follower of self. The leader of self can better play a leading role and draw the follower closer to the target. The leader can improve the ability of global optimization. And it is very important to use an effective objective standard to evaluation the image quality. In this paper, brightness, color measurement, and the information entropy are selected as the objective function, as the direction of self-optimization to measure the image quality. BR represents the image brightness, and to enhance the color of the image, reflecting the vividness of the image. We introduce the information entropy. A performance indicator information entropy is selected to evaluate the image quality. Information entropy represents the amount of information contained in the image. Now, I will introduce the enhancement of image detail layer. In the HSV color space, the brightness component V usually contains a large number of details of the picture. The enhancement of the detail layer of the image is to separate the detail layer into V channel and carry out the restoration and enhancement of the detail layer. First, converting images to HSV space, and the main filter is used to blur the V channel of image B is obtained. The difference in image obtained by subtracting the base image B from the original image V is the detail layer image D. Second, set the enhancement weight T of the detail layer and enhance the separated detail layer T times, which can effectively retain the age information of the image and restrain the image over exposure. Combined with base B and V space enhanced by LLSSA MSRCR, V channel image after detail enhancement is formed. For the comparison in experiment of standard test functions. There are 8 standard test functions selected in this paper. LLSSA is compared with other optimization algorithms, such as self-swarm algorithm, SSA, ant-lion optimizer, ALO, mouse flame optimization, MFO, and the well optimization algorithm, WOA. The experimental comparison results of 8 standard test functions. Each optimization algorithm runs standard functions for 30 times and takes the mean value and the standard deviation of the results for subsequent performance analysis. It can be seen from the table that in terms of average value, the optimization performance of LLSSA is better than that of SSA, WOA, ALO, and MFO. In terms of standard deviation, LLSSA is smaller than that of SSA, WOA, ALO, and MFO, which indicates that the stability of LLSSA and the ability to jump out of the local optimal are stronger than other algorithms. It can be seen from the above analysis that the stability, global optimization ability, and the ability to jump out of local optimization of LLSSA are stronger than other algorithms. And in this paper, 3 objective evaluation indexes, namely mean value, variance, and information entropy, are used to evaluation of enhancement effects. The mean value can reflect the overall brightness of the image. The larger the mean value is, the higher the brightness of the image is. The variance represents the richness of the image gray level. The larger the variance is, the higher the contrast and the more obvious the detail. Image information entropy reflects the storage of image information, as can be seen from the objective evaluation indexes in table. The 5 image enhancement algorithms have improved low illumination images to a certain extent, and the algorithm in this paper has the most obvious enhancement effect on low illumination images. And that's all. Thank you for your attention.
Thank you very much. Maybe somebody have a question to reporter. How maybe I want to ask, what is this your method is how to use it to my images? I have some pictures from my family album and I want to use your method. How it is existing in which form? Is it online, implemented in some languages? It's only theory or is implemented this method?
The algorithm is mainly divided into 3 parts. And first, separate the detail level image of the input low illumination image. And some image details are enhanced according to the weight value set after the algorithm optimization. And second, according to the carefully set fitness function, LLSSA algorithm optimizes the 6 parameters of 3 Gaussian kernels: gain, offset, and detail layer weight in MSR-CR, and achieves the best image quality enhancement for the differences of each image. And the last, the fusion of enhancement image and the detail image according to the weight to generate the final enhancement image.
Okay, thank you. Thank you very much. Maybe somebody else want to ask reporter? Dr. Ning, thank you for your report. We are going to next report.
Okay, thank you.
Thank you. Serhiy Tsibulya, Alexander Lavrut, and others.
Good morning, Nazarkevich Maria.
Okay. Please share your screen. You also have no more than 10 minutes.
Yes.
Less better.
What is presented? Clustering methods analysis for terrain, colors, characteristics, determination. For other Serhiy Tsibulya, Alexander Lavrut, Vasyl Lytvyn, Tatiana Lavrut, Maria Nazarkevich, and Victoria Vysotska. From National Defense University Ukraine, named after Ivan Chernyakhovsky, Hetman Petro Sagaidaczny, National Army Academy, and Lviv Polytechnic National University, and Oshchadoruk University. The formulation problem was color is an integral part of the visual characteristic, material resources, weapons, and military equipment from enemy reconnaissance and destruction maps. It is proposed to identify characteristic colors using cluster analysis, which refers to unsupervised machine learning method. The number of clusters obtained determines the number of colors that will be displayed on the camouflage coating. The result of research with mathematical clustering algorithms were analysis to determine the characteristic color of the terrain. In the Ukrainian, in the slides, in Ukrainian, is a oak forest, a pine forest, grass steppe, and in the article experiments because picture. This is especially true for armored forest of Ukraine, was personal wear, the camouflage uniform of the armies of all countries that help us fight the enemy. However, these uniforms, its camouflage pattern were designed for other theaters of war and are not always suitable for the territory of Ukraine. If you use only one color for camouflage coloring, the product will have a monotonous appearance and will stand out as a spot on the ground. To ensure for effectiveness concealment, the camouflage agent must be painted in the optimal number of colors. Methods was proposed, fighting in eastern Ukraine is currently taking place on a wide front in different natural zones. For example, the contact line which runs south the territory of Donetsk and Lugansk regions is located in the zone grass and fescue steppes. Forests and shrubs cover about 6% of the territory of Lugansk region and 5.6% of Donetsk region. Forests of the gully type prevail, located along rivers on the slopes of valleys, gulls, ravines, and characterized by significant differences. The following species predominate: pine forest in the Siversky Donets Valley, oak, beech, and other. The raw file format with format in image is the data format, contain raw data from optical sensors of the equipment, which avoids informational loss. However, in additional to large file sizes, this format does not have a single specification and difference of each equipment, which leads difficult in processing it. Typically, color represented of 3-4 values called color coordinates. The scikit-learn library provides functionality for clustering using variety of methods: spectral bookclustering, Kaminsk, mean-shift, dbScan optics, based on affinity propagation. Given that the numerical values of the RGB color models are in the constant range on 0 to 255 for each color, it is impractical to scale and standardize the input data. During the research, the images were analyzed using cluster analysis method implemented in the Python programming language using the NumPy, Pandas, SciPy, scikit-learn, and fuzzy Siemens libraries, the Pillow, Yellow Brick, and Matplotlib libraries we used to display in the calculation results. Experiment results and discussion. The elbow method involves plotting the intra-clustering variance, the distance from the cluster elements to its center, which describes of clusters is equal to the number of all objects in the sample. At an intermediate stage, you can see that decrease in the variance slow down in the graph. This happiness point calls elbow. In figure 2, you can see that graph is band cluster 4, number 4, which in your case means that there are 4 characteristic colors of the terrarium. It is possible to increase the number of colors, but it's necessary to check for expediency. In picture 4, show determinate the number clusters, the coefficient method, and picture 5, determinant number of clusters of gaps statistics methods. Figure show values determined by the Kaminsk clusters algorithm of 4 characteristic colors for following terrain types: oak forest, pine forest, herb chaos steppe, and the fuzzy C-means library was used to implement the C-means fuzzy clustering algorithm. For a formula was presented. In the slides presented image experiments, characteristic colors with the values of RGB format and persistence in the image determinants using Kaminsk clustering algorithm, and other image characteristic colors with their values in RGB formats and percentage in the image determinants using fuzzies C-means clustering algorithm for oak forest, pine forest, grass steppes, and parameters for presented in table 1 for a planned image for the slides. And results, original image, forest, steppes, grass, initial colors, and results for applied comments. And conclusion is the results for the research mathematical clustering algorithm where analysis to determine the characteristic colors of the terrain. The need to conduct these studies is due to the lack of universal way determine the number of clusters and was based on the research of all this science who determines that for each subject area only central clustering algorithms work most effectively, which must determine experimentally. Thank you. Thank you.
Thank you for your report, Dr. Nazarkevich. Any questions from participants before we going to coffee break? No questions. Thank you again. And it's the end for this part of our meeting, and we have 10 minutes of coffee break.
Thank you.
Thank you. Okay.
Kirill Smeryakov, yeah?
Yes, we are here,
Olga
but our
Kochko.
presenter is Olga. Olga, please.
Okay. We are ready to listen, Olga.
Hello, everyone. I would like to represent our work building quantile regression models for predicting traffic flow. Almost all cities in the world face serious congestion problems. Excessive traffic flow leads to the paralysis of the urban transportation system on a daily basis, which creates great inconvenience and a negative impact on people's travel. Different countries are actually taking appropriate measures, for example, redirecting traffic, limiting the number or expanding the scale of the road network. But these measures may have little effect. The relevance of this work is to find tools for managing and monitoring this process in cities. According to the developing but still insufficient scientific literature, which focuses on how the dynamism of intelligent transport system affects on urban innovation and how traffic management tools can be activated to obtain optimal results, it's important to analyze urban transport systems as a dynamic whole. The aim of our work is to research the efficiency using quantile regression models for predicting traffic flow, to evaluate the accuracy of these predictions and describe the applicability to improve the road traffic system. Most of the traffic data is provided by taxi services. There are several large taxi services in Kyiv. One of the largest is Uber. It contains data from January 2018 to March 2020. The data is divided into sets, each of which contains information about the average taxi speed on a segment of the region's road for each hour of each day for a particular month. The data includes only those observations for which there is data on at least 5 unique trips on this segment at this time point. The choice of quantile regression for traffic forecasting is reasonable for several reasons. The mean value of the dependent variable, but also several quantiles of the distribution of this variable. This is important for traffic forecasting because the speed of traffic on the roads can be quite different at different points and times. Secondly, quantile regression is less sensitive to outliers in the data than classical linear regression, because quantile estimates are less sensitive to values than deviate from the mean. So it allows to take into account the uncertainty and randomness of traffic data. It's important for traffic because the speed on roads can depend on many factors, such as the number of cars on the road, the presence of traffic lights, a road sign, and others. Based on the selected dataset, the following machine learning methods we chosen was k-nearest neighbors, random forest, gradient boosting, and XGBoost. To assess the prediction accuracy of the chosen models, we use 4 statistical scores: mean absolute person error, mean absolute error, mean square error, and root mean square error. On the next 2 slides, you can see result of our experiment for all our models with charts and tables. Gradient boosting and XGBoost methods show good results for the medium, and this metric is quite close to the MSE. However, for low quantiles, the prediction should be more conservative. This method may be less effective. As we can see from the results, KNN and random forest show not better results in accuracy, but how narrow predicted interval and don't cover all possible values. KNN methods show a narrow interval because it uses the most similar values from the training data set to predict the target regression. A larger value of MSE indicates that a model has a higher dispersion of errors around the predicted quantile values. In other words, the model may be overestimating or underestimating the actual quantile values by a larger margin. And in conclusion, we got knowledge We got knowledge that KNN and random forest algorithm work relatively well for lower quantiles, but their effectiveness declined for higher quantiles. Gradient boosting and XGBoost method showed poor results for lower quantiles and the smallest losses near the medium. KNN and random forest method have a narrow prediction interval and don't cover all possible values. Gradient boosting model appeared to perform the best. In the future, we plan to conduct research and compare the effectiveness of other machine learning methods that can be applied for traffic forecasting, such as neural networks. We need to consider the possibility of using different factors. For example, we can add weather information, events in the city, roadworks, and accidents, which will help identify key stress points in cities. So thank you for your attention. Maybe you have questions.
Thank you very much. Please, anybody have a question to reporter?
I have a question.
Please.
When you predict a group of quantiles, 95s, 19s, you train separate model for every quantile, or some models predict a group of quantile in the same time?
Models predict for 5 quantiles that was represented on the results.
No.
For 5 quantiles.
You predict quantile 0.1. Then predict quantile 0.9. One mod you use XGBoost. How many models were trained to predict these quantiles? One or two models?
One model.
One model. And what was the objective of this model? I'm interested in it. I can't predict 99 quantiles by one model in the same time. 99 outputs from CatBoost or XGBoost I can't have. How to do that with XGBoost? All 5, as I see on you have outputs for quantile 0.1, 0.25.
Yes, I know that gradient boosting have already algorithm for this, but for XGBoost, KNN, and random forest isn't exist, and it was the aim of this research to develop these algorithms.
May Kirill help us with this question?
No, I can't. This is your research.
I can't understand how XGBoost always gives one output for one objective function, for one result. For it can predict one of quantiles at the same time, as I know. How could you do that? It predicts many quantiles at the same time.
I don't understand the question.
Okay, I do the same as your experiment. I need to predict 99 quantile for
Okay,
some.
I understand. We find the lowest and the lowest and value and comparative with the sum operation, each value with medium and the highest value. And this value we
You
Okay.
make a normal distribution from it, or which way?
yes, about distribution.
Okay, yes, thank you.
Thank you very much. Maybe I want to ask maybe not so complicated question. What is the time scale of these data points? Predict.
For experiment was we used data for 1 month. It was January 2020. Data in Kyiv.
1 month. I see prediction and
Yes.
X 120. It's 120.
It's training data. This count of training data.
Number of data. Okay.
Yes.
Thank you. Any other questions maybe? No? Thank you for your report, and we are going to next report. Next report is research on virtual monitoring method based on digital twin smart factory. Dr. Zevan, okay. Yes, we see your screen.
It is an honor to be speaking at this year's conference, and I'm grateful for the opportunity to share my ideas and research with such a distinguished group of experts. My topic is research on virtual monitoring methods based on digital twin smart factory. The main three aspects of my visits are introduction, methodology, and experimental result. As the development of the new generation of information technology continues, manufacturing is exploring transformation for the physical world to the information world, achieving interconnections and intelligent operation between physical and information world. This has become a trend in the world industrial development. One important component of intelligent manufacturing is automated assembly lines. With the widespread use of the automated assembly lines, large-scale production demands can be met, significantly improving the economic benefits of enterprises. However, traditional workshop monitoring methods mainly relies on manual recording, 2D reporting, and configuration monitoring, resulting in wartime performance and visualization effects. In this paper, we utilize Unreal Engine 4 and 3D point cloud data to construct a one-to-one virtual space of real physical space. For real-time data transmission, we can remotely monitor the working status of robots on the production lines in 3D virtual space, achieving transparent and intuitive monitoring of production line and automatically realizing the integration of virtual world and the real world. In this paper, we propose a digital twin smart factory virtual monitoring system based on 5-dimensional model. The system architecture is divided into 5 layers, namely the physical layers, transport layers, information processing layers, virtual layers, and application layers as illustrated in the figure. The physical layer serves as the foundation of the entire framework, consisting of the production environments and various devices such as robots, control cabinet, and sensors by transmitting operational data from sensor in the physical layers to the virtual layer through the transport layers. real-time data mapping between the two layers is achieved. The information processing layer plays a crucial role in processing, transforming, and fusing data collected from various sources to generate valid data. They can drive the digital twins. The virtual layer is an essential component of the digital twin smart factory virtual monitoring system, providing a realistic representation of physical layers and its dynamic and static characteristic. The application layers serves as the user interface, providing functions such as 3D visual monitoring and operation status reproduction. In this study, we propose a method to enhance the realism of virtual scenes by generating point cloud data from status objects using radar scanning. The obtained point cloud data is then imported into UE4 with point cloud support, allowing us to extract accurate information about the size and position of the status object. By utilizing this information, we perform secondary editing in UE4 to create a more realistic layout. Furthermore, to further enhance the realism of the virtual scenes, we add appropriate lighting and render the objects. The figure shows the physical space and the virtual space respectively. Robot and effector trajectory visualization refers to the process of visually presenting the trajectory of robots and effector in a graphical format. By visualizing the end effector trajectory, it becomes easier to understand the robot's operational status and motion trajectory, which in turn facilitates the analysis and optimizations of the robot's motion and planning and control. In UE4, particle system can be used to achieve the visualization of robots and effector trajectory as illustrate the accompanying figure. The physical and virtual spaces are located on different platforms, ROS and UE4 respectively, and thus it is essential to establish a communication link between them. The ROS platforms ROSBridge offer a JSON interface between ROS and no ROS platform, making it possible to establish data communication between the two platforms using a variety of communication methods. In UE4, the ROS integration module is used to connect UE4 with ROS, acting as a client in ROS system. It connects to the ROSBridge server using the WebScott protocol as a communication intermediary, thereby enabling bidirectional communication between ROS and UE4. Twin data is a critical component of digital twins, which include both the statics and dynamic data. They can build a physical space. Static data encompasses information such as the geometry, shape, size, and layout of the device, usually transformed from real-world data captured by sensors. Dynamic data, on the other hand, is the operational data generated during the device operation and is a key part of achieving real-time mapping. In this article, the dynamic data mainly comes from the UR5 robot and AGV car. The twin data of UR5 robots include current timestamps, joint length, joint position, joint velocity, joint accelerations. The dynamic digital twin data of AGV include timestamp, position, and direction in space. The experimental procedure is to send a motion command from the controller to the robot drive, which drives to the robot's motion. The entire operation of the robot is monitored in the monitoring system. The virtual mode successfully tracks the robot's movements and displays the real-time operational status of the device entity. To demonstrate the real-time capability of the digital twin system described in this article, we have collected the timestamps of 4 adjacent data points in each of the 3 stages, with the system runtime as the reinforced 0 point. This timestamp are listed in table 1. Based on the table, it can be observed that the average time intervals between the adjacent data collections for stage A, B, and C are 0.207 seconds, 0.204 seconds, and 0.167 seconds, respectively. And this further confirms the excellent real-time performance of the proposed digital twin system in this paper. During this experiment, the robot's real-time data was recorded while it was in operation. This data was later caught from the system database to reproduce the robot state and verify whether the reproduced state was consistent with the actual running state. To ensure data accuracy, the historical data was compared with the real-time data sent by the controller. For instance, table 2 shows an example of historical data field. J angles to J6 angles representing the received angles values in degrees for each of the 6 axes, which table 3 displays the real-time data sent by the controller. The above data was inputted into the formula for mean the absolute percentage error, and the calculated error between the replicated state and the actual operating state was only 0.1465%, demonstrating the reliability and accuracy of the data. Thank you for your attention.
Thank you. Thank you. Maybe somebody have a question to reporter. No questions. Thank you. Thank you again. We should go to next report. Олег Руденко, Олександр Бессонов, Катерина Ващенко, Софія Руцька. Synthetic dataset generation for efficient neural network training.
Hello.
Will report. Яна Шедловська? No. Катерина Ващенко. Okay. Who will report it?
Катерина Ващенко and Софія Руцька.
Both. Okay.
One moment. We will show our presentation. One moment.
Synthetic dataset generation. Interesting.
Thank you. Hello. I'm sorry. I have not stability internet. So.
No problem.
Thank you. Thank you for your.
Yeah. Yeah.
Oh.
Session chairs.
Just. Okay. This work was made by Oleg Rudenko, Alexander Bersonov, Sofia Rudzka, and Katerina Vashchenko. It's always a big problem to prepare a good data set for neural network training. Usually it's impossible to take many photos for real life because privacy, ethics, and costly equipment. In this work, we consider synthetic dataset. We decide generate from 3D models of the objects. As an example, we choose the task of recognizing requires at the scenes of disaster to better coordinate their action in a full-scale war in Ukraine.
It's also very difficult to get annotated photos. Annotation is a selection of the right object by contour. Imagine you want to annotate one person. That's a lot of work because we needed to annotate a very complex shape. Annotation is a monotone because it's a processing of thousands of images in our project. We intend to make this as automatic action.
We are not only ones who have decided use of synthetic data. Microsoft create realistic, multi-faced and lifelike synthetic faces. Start with universal face template and for example, article systematic review of deep learning based image synthesis medical imaging. The article examines application of synthetic data to improve training of deep neural network in medical diagnosis and treatment tasks.
Synthetic data can solve a large amount of problems of a deficit of real object images. And for example, increase the data set for machine learning, where there is not enough data to test or when privacy is the top of priority. Synthetic data can replace real images. First, it's quickly and cheaply. You can quickly and cheaply produce as much data as you need. And also synthetic data can have better annotations. Synthetic environment can be easily modified, and synthetic data can be used to resolve privacy concerns. Neural network training can be performed on fully or partially synthetic data sets, but at the same time, test set must contain only real objects. Synthetic data, which refers to artificially generated data that mimics real-world data, has a wide range of potential applications across various industries. For example, synthetic data can be used in the machine learning, autonomous vehicles, video and game developments, robotics, security, and fraud detection.
Overall, synthetic data has the potential to be used in a wide range of applications where real-world data may be difficult, expensive, or impractical to obtain. By generating artificial data that mimics real-world scenarios, synthetic data can help to improve the performance and accuracy of various systems and algorithms across different industries.
Deep learning algorithms, in particular the convolutional neural network, CNN, have gained wide acceptance as a robust approach for learning predictive future directly from raw images. The basic principles of future extraction with CNNs still apply. CNNs scan every pixel of an image and store information based on pixel value patterns.
We use the Masker CNN neural network because it's a fast and reliable neural network for detecting object in the image. The search object is highlighted on the contour with the help of a mask. The concepts behind Masker CNN have undergone a step-by-step development through the architectures of several intermediate neural networks that solve different problems. Masker CNN was development from faster CNN, a region-based convolutional neural network. by adding for predicting segmentation masks on region of interest in parallel with the existing branch for classification and bounding box regression. In convolutional neural network, widely used for image processing, can be used to train the network classification tasks. Typically, the last layer of convolutional network has a softmax activation function that converts that the new network output in probability of belonging to each class, and cross entropy is used as a loss function training the network. The stochastic gradient descent algorithm used to train the convolutional neural network formula on the slide.
In our work, we followed this order. First, you need to find or create a 3D model of the object being explored, and a 3D model of the environment, and create the design. Then render the image, and if that's enough, you can move on the next step. With the 3D models, it's easy to make masks, and with the software calculation, you can find masks. Coordinates are saved in a JSON file for future processing and saving object boundaries. That's how annotations are created. In the process, we changed the appearance of the background in many ways. We added destroyed cars and houses to fully replicate the scene of the city photo. We added different weather conditions, such as rain and snow, which will eventually make up the complete scene.
This project used Blender, professional free and open software for creating 3D computer graphics. 3D models also make it easy to create masks of the object in a single click. In a Blender, it's possible to animate characters or different objects. You can see example on the slide.
The annotations are needed to mark the boundaries of the desired object. Of all programs, we decided to use VDG Image Annotator. It's a simple program, but it takes a long time to process a single object. We developed a program that receives the coordinates of an object's boundaries. It speeds up the annotation process. Just load the image and its mask into the program. The mask is a photo with a completely black background on which the object is marked in white. The resulting point coordinates in the JSON file are loaded into VIA, and the mark area appears on the object, making it easy to annotate.
Our dataset has also been augmented. It's when the photo mirroring, rotating, zoom, contrast, flip, and etc. After modifying the photo, object boundary photos points, object boundaries points change. They now have different coordinates, and our program sets automatically its new points. We trained the neural network on a test that contains synthetic images. After training, detect object already in real images. We ran this neural network using cloud services, which allowed us to use Google GPU. Processors are expensive and not everyone can afford them. So this method simplifies, this method can save money. And we use Google Collaboratory. After testing the neural network, it turned out that turnout of 150 real photos and 40 are not recognized accurately. This can be solved increasing the neural network training by large numbers of steps. In a situation where there's no way to take many photos, it makes sense to use synthetic data. That what is done in programs such as Blender. The resulting images need to be annotated. For thousands of photos,
photo and take days or weeks if it does not have a perfectly straight shape. We are writing a program that will do the annotation in just a couple of minutes. And the resulting synthetic images, we trained a neural network that already recognizes the object we need.
Working on the project gave us the idea that could be incorporated into the development of the VR glasses industry. For example, for operator who coordinates the work of requires, and they allow seeing literally in front of him in real life. This technology can find any object in the image, and it's may be used everywhere. Thank you for your attention.
Thank you for attention.
Yeah, thank you very much. Very interesting.
Thank you.
Please, questions to reporters. Maybe somebody have a questions. For example, how to compare results of network learning by these synthesized data in comparison to real photo data. How to compare? Maybe it much worse result will be when we use the same amount of data synthesized and real.
You ask about how compare results or how compare
how to compare training with synthesized data and the real data.
Okay, we can compare for no, in the results no, for example, if we do learning in real images,
yes.
No, for example, we have one people in the photo. No. For example, my hand. We should annotate it. It have time.
Yeah, I understand that it's much complicated to annotate and so on.
Yeah. In synthetic data, we can no. For example, we use Blender. Just 3D models. We take like take photo of screen, and we receive mask. Mask is when completely black background in photo, and our research object delighted in white. We have problem which set point on boundaries in object, like if you will annotated hand, and it's like it's automatically action in our program. Like you don't need annotated something. just
We understand that it's better, much less work to prepare test training data. But when we have real training data, it was expensive but real, and train our network, neural network, by real data, and then instead train neural network by synthesized in Blender data and compare result. Maybe it's much expensive real data, but much better result of training. We pay by this.
We can yes, compare. We can compare our result in synthetic data sets and in on real photos, and it's almost the same result.
Result of training. Yeah.
Yes, yeah. It's not the same, but almost the same.
Okay.
And on synthetic data set, like for me, I think it's better because it's like new step for
Please, Sergey, we are listening you.
I have a question.
Please, next question.
Mask is produced by Blender itself, as I understand.
Yes, it's itself in Blender, just for it's no, like in Blender, it's just maybe 2 click. Just
okay, that's perfect. And one more question: can Blender produce distance to every point from point of view, as mask produces? Can produce distance, mask or matrix of distances?
Distances of what?
From point of view, from
camera.
From camera to rendered point, man or wall.
Okay. And which question? How distance? No, like you can no, you can move camera on Blender and
No. As it produces masks in 2 clicks, maybe it can produce distances to make 3D model, for example, by to model by neural network the distance to. I want a neural network to understand which object is closer to us and which is far from us. Was it?
No, like you no, for example, you have different objects in your screen, yes, and you can group, for example, buildings requires cars and like groups, and no, just you have checkbox like with show on render. You should just select checkbox, and in render you haven't this object.
No, distance from what is more close for us and what is far from us to understand instead of mask. Mask is 0 and 1, object or not, but distance is distance to that object, distance to the wall, distance to tree. Can produce Blender such information for us?
Well, Blender has many tools for switching distance, like a ruler, or when how close the object to camera when we want to render image. Yeah, it exists, but
Oh, thank you. That's perfect.
Maybe ruler, yeah. Okay.
Yeah.
Yes, Blender is good too. You should study what it could or what it not. Thank you. Maybe some other questions or not? I think that we have no question. Very good work. Thank you very much for your participation.
Thank you.
Going to next, last report for today. Sergey Vladov, Yuri Shmelev, Ruslan Yakovlev, Marina Petchenko. Modified neural networks, fault-tolerant closed on-board helicopters, turboshaft engines, automatic control system.
Good afternoon. Do you see my presentation?
Yes, we see.
Thank you very much. Good afternoon. With your permission, I present a work. Modified neural network, fault-tolerant, closed on-board helicopters turboshaft engine automatic control system. It is known that the assessment of helicopters turboshaft engines operational status in the condition of their flight operation is carried out as a rule according to a limited amount of information due to the small number of standard controller parameters. This significantly limits the effectiveness of parametric methods based on the identification of mathematical models of engine workflows. Therefore, it is relevant to conduct research to improve the efficiency of turboshaft engine operational status monitoring, including the method of neural networks. The analysis of modern literature devoted to the neural networks and neural network control systems shows that despite the ongoing active development in this area, many issues related to the development of algorithm and method for identification nonlinear objects based on neural network models, synthesis of the structure and adaptation, training, algorithm for the parametric of neural network controllers, features of the implementation in multi-mode control systems for nonlinear dynamic objects. All of the above fully applies to such a dynamically complex class of control object as helicopters turboshaft engines. The helicopter's turboshaft engine closed on-board automatic control system was developed by this authors group and is shown in figure. As an effective way to ensure fault tolerance, you can use the so-called active approach based on the reconfiguration of the neural network controller using a selector in case of emergency situation in the operational of the automatic control systems. Bottom figure shows a diagram of the closed-loop helicopter's turboshaft engine automatic control system, in which a supervisory neural network is used to tune the parameters of a linear PID controller depending on the engine operational status and external conditions, compared to the classical tabular methods of approximating the coefficients. The neural network approximator provides more flexible adaptation training to change in external condition and helicopter turboshaft engine parameters. Thus, the modified closed onboard helicopter's turboshaft engine automatic control system is presented on this slide. For the purpose of signal of parametric adaptation, the developed automatic control system is supplemented with connect adaptation modules that implement adaptive control methods. Signal adaptation module, parametric adaptation module, linear model submodule, customizable model submodule. To solve this task, the method developed by Professor Volodymyr Vasyl were applied. A multi-layer neural network of the perceptron architecture with 3 neurons in the hidden layer and 1 neuron in the output layer is taken as a neural network controller. The total number of weights of synaptic connection, configuratable parameters of the neural network controller, 9. Type of neuron activation function, tangential sigmoid. At the same time, it is proposed to use a variable training rate parameter for each layer of the neural network as a function of the error of the neurons of the corresponding layer. The input data for training the neural network are the following parameters of helicopter turboshaft engine, which are recorded on board the helicopter. From the one shown in this figure of the transient from the one shown in this figure on the transient process in the follow that the automatic control system with a neural network controller provides the best quality of control. The dynamic control coefficient is 6 times less. The control time is 2 times less compared to a system based on a PID controller with constant settings. This figure shows gas generator rotor RPM signal timing diagram with continuous disturbances and operation of gas generator rotor RPM. Automatic control system with a without neural network adaptation. The results of comparative analysis are present in this slide. The conducted experimental research has shown the feasibility of using a multi-stage neural network controller in modified closed onboard helicopter's turboshaft engine automatic control system. The conclusions are presented on this slide. Thank you for attention. Thank you very much.
Thank you. Any questions to reporter? This optimization of work of turboshaft engine for helicopters and listen, not at first time, but not enough knowledge to compare this report with previous. Okay.
Thank you. In this work, we have results of identifying a neural network controller comparative analysis. We used classical methods, least squares methods, graph argument according methods, and neural network methods. perceptron and RBF network. The small error we have when we used the perceptron, and this error is 0.267, and we optimizing the parameters of helicopter's turboshaft engine was according to recorded on board of the helicopter, there are gas generator rotor RPM, free turbine rotor speed, and gas temperature in front of the compressor turbine. This parameters is okay. This parameters was optimizing and are main parameters.
Okay, it was in the report. Okay, thank you.
Thank you.
Maybe somebody wants to ask questions. Nobody. Then it's end for today. We are listening almost 12 reports in this session, and thank you for active participation, and see you next time. Thank you very much. Dear colleagues, tomorrow will be next session. Please be present. And for today, bye.
Thank you. Goodbye.
Thank you. Goodbye.
Thank you. Goodbye. Thank you.